In this video, we are going to talk about integration by parts. I will give you the formula and then I will give you a proof about how they came up with those formula, and then I will give you a couple examples. First of all, before we start, there are two popular integration methods. The first one is U substitution. The second one is integration by parts. So later on, when you take higher level math and integration is required in a specific topics, most likely you will have to know how to do U substitution and integration by parts. So we have two lines of formula, one for indefinite integral and one for definite integral. For the indefinite integral, we have the integral of u dv, the blue line, equals to uv minus the integral of v du. I know you have never seen that before. It looks very complicated at this point, but I will show you how they came up with this. And then the second line is for definite integral. You have the integral x goes from a to b, f of x times g prime of x dx, that is equals to f times g, such that x goes from a to b, minus the integral from a to b, gx times f prime of x dx. I know that looks very complicated as well, but I will show you how to get there in a minute. So how do we come up with this formula? First of all, we have to recall the product rules. Differentiation. So you learn this in differential calculus. So the product rule is you are taking the derivative of the product of two functions. So on the left hand side, you are taking the derivative of f times g with respect to x, the d dx. The d on top means the derivative. The dx in the bottom means the independent variable is x. So what is the product rule? The product rule is f times g prime of x plus g times f prime of x. So you are watching my video, right? You know that I would like to keep things simple. So let's take away the independent variable x. So if you look at the next line, that is my product rule. So I have f times g prime, that is equals to fg prime plus gf prime. So that is the product rule in simple form. Forget about all the x. fg prime plus gf prime. How do we came up with the integration by parts? So the first step is you have to integrate both sides. So do you see that I have a red integration symbol? Integrate both sides. Okay, so after you integrate both sides, so the next line is we have integral. Now, go back to the first line. Do you see that we have fg prime equals to f times g prime equals to fg prime plus gf prime, and then I am taking the integral of the left hand side, right? So what we are going to do is we are going to bring this part, bring the right hand side to the integrand. So what we are going to write is fg prime, so fg prime plus gf prime, and then that is equals to, what about the other side? The integral of fg prime plus gf prime. So the right hand side, do you see the green underline, is the derivative of the left hand side, right? So once you take the integral, do we agree that we just undo the derivative? Let's do this again. Look at the second line, the integrand on the right hand side. Do we agree that that is the derivative of the product rule? If you look at the first line, the right hand side is the derivative of the left hand side. Once you integrate the right hand side, we just undo the derivative. That means we go back to the left hand side, which is fg prime. I mean just f times g. We just undo the derivative. Once you integrate, we just undo the derivative. So just f times g. And then do you see that on the right hand side? So let's say we have example. I should do that in another color. So let's say we have an example. Let's make this simple. Let's say we have the integral of x squared plus ln x dx. Do we agree that that is equal to the integral of x squared dx plus the integral of ln x dx? We can split it up into two integrals, right? Same concept applies here. So we can do this. The integral of fg prime plus the integral of gf prime, no change on the right hand side. Okay, and then we are going to bring this to the other side. So it was a plus, so now it's a minus. We have integral of fg prime equals to f times g minus integral gf prime. And then we have to define the f and the g. So how about this? For the f, I am going to call this u. So the f, I am going to call this u. So this f, I'm going to call this u. And then the f prime, the f prime. So when you do the f prime, so let's say the independent variable is x. So there is a dx in here, right? So I am going to call the entire thing du, the derivative of u. And then what about the g? So the g, let's do this right here. So the g, let's call this a v. The g, let's call this a v. So the g prime, then that will be dv, right? The integral of function v. So that will be dv. So do you see that the u's and the dv's? So now we can write things as the integral of u dv equals to u times v minus the integral of v du. So this is what we have for the indefinite integral. Which is the first line over here. Indefinite integral. The integral of u dv, look at the blue line, equals to uv minus the integral of v du. That is exactly what we have right here. What if I give you an indefinite integral? So if I give you an indefinite integral, so that will be the integral from a to b, and then we have f times g prime. So that is equals to f times g. We are taking this line right here, and then such that x goes from a to b, and then minus integral a to b, and then we have g times f prime. So there is a dx, assuming x is the independent variable, and this is for definite integral. So that's how they came up with these two formulas. Let's take a look at a quick examples. So let me give you a quick example right now. So the quick example, let's do that in red. So how about this? We have the integral. We have the integral of x to the third times ln x dx. I want to integrate this using integration by parts. So you have to do four things. So the first thing is you have to let u equals to something that is easy to integrate. I will just do ln x, and I will show you why I let u be ln x, not x to the third, in a minute. And then you take the derivative of that, just like the u substitution, 1 over x dx, and then look, and then you have to set up a dv. So what is the dv? The dv is the leftover. So you already picked the ln x, so you only have x to the third and then dx left, right? So when you find v, what is v? dv is the derivative. If you want the v, that means you have to undo the derivative. When you undo the derivative, that means integral x to the third dx, that is equals to 1 over 4 x to the fourth. So when you do integration by parts, you have to do these four things first. I want you to do it in this form. Don't put that in 2 lines. Don't put that in 3 lines. Put it in this form. U du, dv, and then v. I want you to do these four things in this order. Don't put them in 1 line. Do them in two lines. All right? And then what do? We have to recall the formula. So integration by parts, that is uv minus the integral of v du. And then we pick up these four pieces and then put them together. So uv, what is uv? uv is uv, so right here, so that is uv. So we have ln x divided by 4 times x to the fourth minus the integral of v, 1 over 4 x to the fourth, and then du is equals to 1 over x dx. We are putting these four pieces together. And then you can simplify this integrand. So you have ln x divided by 4 x to the fourth minus the integral of 1 over 4 x to the third dx. And then you integrate you do the integration, and then that's your final answer. So you have 1 ln x divided by 4, and then x to the fourth minus, so that will be x to the fourth, 4 times 4, that becomes a 16, and then plus c. So that is how you handle this indefinite integral using integration by parts. What if you have a definite integral? So what if the integral looks like this? You have integral x goes from 1 to 2, x to the third, ln x dx. What needs to be changed? This piece needs to be changed. This piece. We are going to put that piece right here. So how do we change that? So here is the changes. You have ln x divided by 4 and then x to the 4 such that x goes from 1 to 2 and then minus the integral from 1 to 2, 1 over x, x to the third, dx. And then you do this, you use the fundamental theorem of calculus, you plug in the 2, ln 2 divided by 4, and then 2 to the 4th minus ln1 is 0, so simple math, 1 to the 4th, and then you minus, you integrate first, so that will be 1 over 16, x to the 4th, x goes from 1 to 2. And then this is 16 divided by 4 is 4, right? So you have 4 times ln2 minus 0, ln1 is equals to 0, and then minus, this is 1 over 16, 2 to the 4th minus 1 over 16, 1 to the 4th. And then you have 4 times ln2 minus, so that will be 16 divided by 16 minus 1, minus becomes a plus, 1 over 16. And then you have 4 ln2, and then you have a negative 16 plus 1, so that will be negative 15 over 16. So that is for the definite integral. All right, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Please like the video for me. Subscribe to my channel if you haven't done so. I will see you all in the next lesson. Signing out for now.